Here we go. Final problem. Problem number 4. Ferrari's method. Here it is. X power 4 minus 8x cube minus 12x square plus 60x plus 63 is equal to 0. How shall we start? Sir, we can start by making a partition line. After the x cube term, we can shift all of these terms to the RHS. That is going to be our first step. Students, please note that if you haven't seen my previous video on the Ferrari's technique, go ahead and watch them. The entire playlist, okay, of all the exercises 1, 2, 3, in fact of this entire chapter, is provided in the description. Go ahead and access it, all the videos. The next objective is to make perfect square both in the LHS as well as in the RHS. How do we do that? Sir, what we can do is we can convert this x power 4 into x square and h square. Similarly, this is a, by the way. We can also split it up into 2ab form. Sir, if you watch this, 2 into a is nothing but x square. Let me write x square over here. B is equal to 8x cube, isn't it? If you solve it, 2x square multiplied by 4x will make 8x cube, isn't it? Yes, sir. So b is essentially equal to 4x. So what we can do is, in the next step, I can split this 8x cube into 2 into x square into 4x. Let me do that. Done, sir? Okay, so we've got a and its square. And sir, we've got minus 2 into a into b. Sir, we can also add a positive b square over here. By the way, this is b and this is a, isn't it? Yes, sir. That means plus 4x and its square. So if you are adding 4x square to one side of the equation to maintain the balance, you have to add 4x and its square to the other side of the equation. So equilibrium maintained, no problem. Now what? 16x square, 12x square. This is going to make 28x square. That's the first thing. Secondly, a square minus 2ab plus b square. So x square minus 4x and its square. LHS has been converted into a perfect square. Now the idea is to introduce lambda. Okay. All right. So we always kick off with a plus b plus c and its whole square. Take 2c as common. Now start introducing lambda. Lambda. This is what you get. Okay. On the RHS, you already have 3 terms. The lambda square term, this is missing. This is also missing. By the way, that's a and that's b. Right? So plus lambda square plus 2 lambda a plus b, that is x square minus 4x. Here it is. Let me write it. Done. Okay. Very well. Now, so what we can do is we can take x square as common. We can write 28 plus 2 lambda. Here it is. Similarly, sir, x can be taken as common. This is negative 4, 2 is 8 lambda. This is negative 60. So negative x, let me take it as common, and inside the bracket we'll have 8 lambda plus 60. And these are the remaining terms. By the way, that's going to be our master equation. Once we have the value of lambda decided, we can plug it into this equation, and then we can finally conclude the Ferrari's technique. Okay. Let's focus on the RHS part. Take a look. It looks like ax square. This is bx and this is c. Isn't it? For this RHS to be a perfect square, that discriminant has to be 0. That means negative 60 plus 8 lambda and its square minus 4 into a into c is equal to 0. Do the expansion. Do it. You know the stuff. Multiply both the terms inside the brackets. Here it is. Multiply minus 4 inside. All of these signs will reverse. Okay. This negative will become positive. This positive will become negative, and so on. Now arrange the terms in a very sophisticated fashion. Negative 8 lambda cube. Write it down. Then you've got plus 64 lambda square minus 112 lambda square. This is going to be minus 48 lambda square. Okay. And the remaining terms can be worked out very easily. All right. So, sir, we can observe that all of these terms are easily divisible by 8. Please check it with the help of a scientific calculator. Okay. That's allowed, by the way. You all are engineering students. This calculator is allowed. Let's divide by minus 8. The benefit is all of the terms are easily divisible. Okay. So the equation will be reduced. And secondly, this negative lambda cube will become positive. That's an advantage. Let me do that. Done, sir. Now, with the help of a calculator, we'll be calculating the value of, or the 3 roots of lambda. Okay, shift 9 3 equal to. Okay, here we go. Watch. Go to mode, hit 5 for equation, hit 4 for cubic equation, plug in the values of A, B, C, D. A is 1, B is 6, C is minus 183, D is minus 1332. Done. Hit enter once again. You can see we are basically interested in the integer values of lambda. That's not an integer. This also isn't an integer. That's an integer. Okay, although a negative one. But since our hierarchy is that if you've got 3 values of lambda, we go for the smallest positive integer. Here, 2 values they are not integers. So there is only one value left, which is an integer, but it is negative. Therefore, select that negative value and go ahead. Okay, if your teacher does not allow this technique, what you can basically do is you can simply say that, sir, I have found out that when I plug in the value of lambda is minus 12, this equation becomes 0. And then what you can do is you can use this synthetic division technique. Let me tell you how that works. Lambda is equal to minus 12. What are the coefficients? Sir, 1, 6, minus 183 and minus 1332. Use the synthetic division technique so that this cubic equation can be converted into a quadratic, and then that can be solved easily either by factorization or by Sridharacharya formula. Okay, divided by minus 12. You know how this can be done. This has been explained on numerous occasions in my previous videos. Okay, when I taught you about transformation of equations and stuff like that. Go ahead and do it. By the way, there are 3 values. These are not integers. Okay, there is only one integer left. Although it is a negative one, we are going to go with that. Negative 12. Let me plug it in over here. All of these 4 locations. 12 2 is 24 with a negative sign. 28 minus 24 is 4. Similarly, you can work out 60 minus 12, it is 96. 60 minus 96 is minus 36. Minus is plus 36. Okay, sir, this can be written as 2x and its square. And also this 81 is a perfect square of 9 square. Okay, 2 into A into B. Perfection. A square plus 2ab plus b square. So 2x plus 9 and its square. Done, sir. Very easy. Bring this term to the LHS. Done, sir. A square minus b square. A minus b minus b. A plus b. A plus b. Done, sir. Minus 4x minus 2x is minus 6x. Similarly, minus 4x plus 2x is minus 2x. Done. Okay, sir. Can we factorize it? Can we simply solve it by factorization? No, this cannot be solved by factorization. So you have to use the Sridharacharya formula. Okay. A is 1, B is minus 6. And C is minus 21. Use this formula. Minus B plus minus under root of B square minus 4AC upon 2A. Okay, and this can be factorized very easily. Watch. Inside the root, this will turn out as positive 120. 120 is 30 into 4. So this is going to be 2 root 30. Okay, 2 root 30. 2 will cancel. 2 3 is 6. 3 plus minus root 30. That's your, these are the 2 roots, one positive, one negative. Similarly, you can split it up. Take a look at this quadratic. Minus 2x can be split up into minus 3x plus x. Take x is common. X minus 3 remains inside. Here, take 1 as common. Take x minus 3 as common. X plus 1 remains inside. So the roots are 3 and minus 1. Okay, 3 and minus 1. 3 and minus 1, and these are the 2 other roots. Right? So yes, that was all from my side. If you appreciate this content, if you like this content, do share it with all your friends and classmates, and do subscribe to the Manas Patnaik channel so that you stay notified with all my latest content. Thank you very, very much, and have a nice day.